We now determine g of 7 using the graph of the derivative function that is g prime. So first I'm going to write down the definite integral g prime of x dx, and this is from 0 to 7, and this basically equals the area under the graph of g of x, the graph of g prime of x. So let's evaluate this left side expression. The antiderivative of g prime of x is g of x, and this is evaluated between the limits 0 to 7, and this equals we find the area under the graph of g prime of x. So let's see how to find out this area using the graph of this derivative function. First I'm going to label some points. Let the origin be noted as O, and this point is A, this is B, this one is C, this one is D, and let's say this point 7 is PE. So to find the area under the graph of G prime, we can clearly see that we have three different areas. That is the region OAB. This one basically is a triangle, and then we find the area of the region BC, which is basically a semicircle, and then add this with the area of the another region, which is CDE. So this one is also triangle. This is triangle, this is triangle, and this one is a semicircle. So let's find the area of this corresponding regions. For the first triangle, we need the base and the height. The base is this length, which is 3 units, and then the height is this length, which is 4 units. So we write down this as the area of the triangle is half times base times height. So it is a half times 3 times 4, plus the area for the semicircle. The radius is 1. The area of the semicircle is pi r squared divided by 2. So we can replace r by 1. So therefore this becomes pi times 1 squared divided by 2, plus the last triangle. We have the length of this triangle is 2 units, and the height of this triangle is 1 unit. So we can write down this as half times the base is 2 and the height is 1. So let's find out this area. So this gives 3 times 4 is 12. 12 divided by 2 is 6 units. And this one is pi times 1 squared is pi divided by 2, plus we can cancel this 2, and so 1 times 1 is 1. So we see that it is 6 plus 1 is 7 plus pi by 2. And on the left side, we can evaluate this as we apply the upper limit first. So therefore this is g of 7 minus we then apply the lower limit. So it is g of 0. And so we can replace the value of g of 0, which is already given as 3. So therefore I can write down here that is g of 7 minus g of 0, replace that by 3. And so we can find a g of 7 from this equation by adding 3 to both sides. So when we add 3 to both sides, this one is 7 plus 3, which is 10 plus pi by 2. Okay, there is a little correction over here. When we consider the area of the semicircle, we should consider it is below the x-axis. So evaluating that area, we will get negative. So we should mark this area as negative for the semicircle. So it will be negative. This is negative. This is also negative. I replace this by negative. This is negative. And so we get this one is also negative. So the answer to this question is 10 minus pi by 2, which means option C is correct.